This video is going to finish up section 7.2, which are reactions where we have a solid precipitate formed. So in the previous video, we talked about a precipitation reaction, and we talked about how ions break up or separate, dissociate when they're put into water. And we know the difference between a strong electrolyte and a non-electrolyte. And we looked at a double-date switch, and we looked at what the possible products could be when we put them together in the container. And how do you know if there's a reaction that occurs? Well, we're looking for a solid to be formed. So that's what we have worked on so far, and what we've looked at is how to determine whether we have a solid product or not without doing the reaction in the lab. So the general solubility rules are listed in your textbook. It's one of those you need to keep a handle on what page they're on so that you can go back to them. One of the things that I've noticed we've had a little bit of problem with is the difference between soluble and insoluble. So insoluble, in this case, means not. Soluble means dissolvable or dissociates when you put it into water or mixes with to where you don't see it anymore. Slightly soluble means it doesn't really dissolve very much. It may a little, but not really enough to count. So if you come across something that is insoluble or slightly soluble, it's going to be a solid in solution, where soluble means it's going to be broken up into its ions. This form of the solubility rules may be easier for you to look at, or maybe help you remember them a little bit easier. It's not something you have to memorize, but the more we use them, the more you'll remember them. These are all soluble compounds. That means that they will dissociate and be ions when put in a water solution, in an aqueous solution. These are insoluble compounds, so that may be a helpful visual aid for you when we're predicting those as well. So let's just go step by step how to predict precipitate when solutions of two ionic compounds are mixed. First thing, you're going to write the reactants as they actually exist before a reaction occurs. Remember, when a salt dissolves, you have ions. You consider the various solids that could form, which is the double-date switch, and use the solubility rules to decide whether or not you're going to have a solid that forms. And if you do, you can then predict the identity of that solid. So which of the following ions form compounds with lead-2 that are generally soluble in water? So you have to go back and look at your solubility rules before we answer this question. And when we look at those, it says that which one of those, it wants to know which ones are generally soluble when it combines with these. Obviously, it's not going to combine with sodium because it's a positive ion, and like do not attract each other. They have to be opposites. And if you go through your list of solubility rules, we'll take a minute just to look. We were dealing with lead-2 chloride, so we need to look for a flag that may be an issue. We know that most nitrate salts are soluble, so if I see a nitrate ion it's going with, it's probably going to be soluble. We don't have to worry about positive ions because it is a positive ion itself. It's not going to mix with a positive ion. If it's mixing with chlorine, the chloride salts are soluble unless you're talking about lead-2 chloride. So here's one that's going to be the exception. This is not soluble. Most sulfate salts are soluble except for, and here again we have lead-2 sulfate. So if it's a sulfate salt, it's not going to be soluble either. And then it says most hydroxides are only slightly soluble except for sodium, potassium, barium, and calcium. Those are moderately soluble. Most sulfide salts, carbonate, and phosphate salts are only slightly soluble. So let's go back to our original problem now. Trying to keep those rules in mind. You'll have your rules, of course, in front of you when you get ready to do your problems, but it wants to know which ones are going to form soluble compounds. And if you remember, the sulfide and the chloride salt and the sulfate salt were actually some that were listed as insoluble. So in this particular circumstance, only the nitrate salt would be soluble in water when it's connected to the lead-2 ion. And that's how you use the solubility rules. You just go back and you check them and you compare them, and then you make a judgment call as to whether or not it's going to be soluble or insoluble. We'll do one last example for this section. This is similar to number 15 in your text that we worked on in class. A sodium phosphate solution reacts with a lead-2 nitrate solution. What precipitate, if any, will form? And I'm going to take a minute and pause this so I can set up the reaction and write it out for you. So you're going to have to go with the flow since I don't have my regular pen on here to be able to write. So what you have to do is write out what you have. Don't assume you can just look at this information and come up with an answer. So we have sodium phosphate. So I'm sure this is just going to be so easy to read. Sodium phosphate is Na3PO4. And how do I know that? I did well in the naming chapter, right? And so you know how to do those. We can go from sodium phosphate to the chemical formula, and that's Na3PO4, just in case you're wondering, in case you can't read it. Lead 2 nitrate is going to be Pb, and that's a +2 charge. Nitrate has a -1 charge, so it's going to take 2 nitrates in order to balance out their charges on the lead. So NO3, 2. Now, we did the double date switch last time. So here's our positive ion sodium and our positive ion lead. So we're going to put them with the negative ion of the other one, just like this. So our possible products then would be lead 2 phosphate and sodium nitrate. Lead nitrate is already up here, and it's not going to be a precipitate because this is aqueous in solution. It's not going to just become solid as a product, so that's not even a possibility. The next thing we need to do is look at our solubility rules, and you'll notice on the solubility rules that sodium and nitrate are extremely soluble, so that will not form a product that is a solid falling out of solution. So we look for lead phosphate or lead 2 phosphate to see if that is a possibility of forming a solid. And if we look at our solubility rules, we'll notice that phosphate salts are only slightly soluble, making that insoluble for our purposes. And just to verify that the nitrate and the sodium salts will be soluble, so we will not see those as a precipitate. So to finish it up, we're going to say that the precipitate that forms is the lead 2 phosphate, and using our solubility rules is the way to do that. Like I said, you can have a copy of those when we go through and do these problems. Just make sure that you're consistent. The biggest problem you're going to run into is not identifying probably if it's going to be soluble or not. It's taking the words and going to chemical formulas and vice versa that may throw you off just a little. It'll just take some practice.